Okay, in this video, I want to talk about how we can find the area between curves that are given as functions of y. And in a previous video, we've learned how to find the area between curves that were given as functions of x. And this is going to complete the first part of this particular section's material. And so you have to look at the case where I have a function that only can be expressed as a function of y. So you can think of this passes the horizontal line test. That means x is a function of y. Or if I flip the page right here, since I passed the vertical line test, it means this axis is a function of this axis. Now, that's x, and this one's y. So these are functions of y. And I want to find the area bounded between these two curves. Well, you found out how to do it in this case, and we just took the top function minus the bottom function. So we're just going to do the same exact thing. We're just going to be integrating from here to there from the top minus the bottom. And so if we look at what we have, my top function, you have to really tilt your head to look at, this is the top function, g, bottom function is f, and I have the area is the integral from c to d of the top function minus the bottom function, just like we did before. Just as a quick check, you could think of, if this was your x-axis, you would integrate from c to d and you'd have your integrand top minus the bottom. And that's exactly what we're seeing in this integration expression that we have here. So let's do a couple of practice problems. I've written out the detailed solutions, and I actually have Desmos already, so you can envision what this description is. So just like in the previous notes, the goal is I want to get a picture here. Let me label the axes. This is still y, this is x. If I were to graph x equal to y times 2 minus y, I get a little parabola. It's 0 at 0, and it's 0 at 2 when y is equal to 2. And so when I have that, and I look at x equal to 0, that's the vertical axis. Shoop, right here. I'm trying to find the area trapped between that. So you'll see in your homework, I want to find the area between two curves. It's up to you to find a picture to see what area is being determined by these two functions. Now I'm going to go over to Desmos here. What I did, I'm graphing f, which is y and 2 minus y. So that's that blue function. And I have g of y, which is just x equal to 0. Which is just this vertical axis. So you can read this as x equal f of y, x equal to g of y. This function, you give me the y variable, and it gives you the x coordinate. And so what we're trying to find is the area between these two curves as that integral. And so I can integrate in here, int, I'm going to integrate from 0 up to 2. I'm going along the y-axis. The top function is this function right here. And that's my f of y. My bottom function is my g of y. And I'm integrating over the y-axis, so I'm using dy. If I did dx, that would make it integrate from here to here. And I don't want that. That's an incorrect expression. So I'm getting 1 1/3. And let's look at the exact result. I'm expressing the integral here. And we could now use our power rule by first expanding the integrand to write it as 2y times, or 2y minus y squared. And you can integrate each individual term. By the power rule, 2y is y squared, and y squared is, that should be y cubed, over 1/3, going from 0 to 3. And then I would have, I'm going to update this, this is 8/3 right there. I'd have 4 minus 8/3, and then minus the valuation at 0, which is 0 minus 0. So we get 4 minus 8/3. If we write 4 as 12 over 3, then we get our final result of 4/3, or 1 1/3. And that's how we found the area of that. You know, you could have done the integral this way. You would have had to have solved this function for y. You could do that. You could expand this, bring that x over, use the quadratic formula. You're going to get a top solution and a bottom solution, and you integrate from the bottom to the top from here to there. That's more work. That's a lot of work just to see those details. I have to write out I'm going to write y squared minus 2y plus x equal to 0. I'd have to use the quadratic formula. Okay, so I'd have y is equal to 2 plus or minus the square root of 4 minus x squared all over 2, because 4 minus, 4ac, so I have 4 there. And so if we write that down, we'd have the top branch, well, I'm going to write them as both, 2 plus or minus, let's factor that 2 out, or that 4 out as a 2, and you get 1 minus x squared all over 2. And that simplifies down to the top branch, or the top portion of the function would be 1 minus the square root of 1 minus x squared, sorry, 1 plus, and this bottom portion would be 1 minus the square root of 1 minus x squared. You then have to integrate, and I have the integral. I still got to figure out what that value is right there. That's going to happen when y is equal to 1. When y is equal to 1, x is equal to 1. So we're going to integrate from 0 to 1. Top function, 1 minus x squared, minus the bottom function. And you got to integrate that. That's a very difficult integral, by the way, because those square roots don't cancel. So I'm going to have the square root of 1 minus x squared. Oh, dang. We're going to have to do a trigonometric substitution. You have to say, let x be sine u. And you'd have to go through the rigmarole, where this is not a complicated integral. So there are situations where it benefits you, it behooves you to integrate in a different way. Okay, let's look at another example. Okay, I have a line, x equal y minus pi over 2, which I drew right here. And I have x equal cosine of y. So which has just a hump right here. And I just want to find the area, and I've specified the domain 0 to pi over 2. So we have to get a picture, because it's important to recognize what's the top function, what's the bottom function. And so once I know what the top function is and what the bottom function, then I know automatically what that integrand is. So once I have the integrand, I can go cosine of y minus the equation for the line. So cosine of y minus pi over 2. And then I can walk through integrating term by term to get my exact result. So now you're ready to finish the homework for section 7.1a, which gives you integrals, or finding the area between curves that are expressed as functions of x and functions of y. In the next following video, I want to find, how do we find the area between curves, or between two curves that have multiple intersection points. And so there's going to be a little bit extra work to be able to figure out the resulting integration ranges. And right now the integration ranges are fairly simple and straightforward.